Lesson 4.6, isosceles triangles. So we have these triangles, nice little sculpture here. So if you end up going into art and making sculptures, you can kind of consider all the math you've learned and just incorporate it into some nice, beautiful sculpture like that. There's lots of isosceles triangles in there, and I think I see an equilateral triangle as well. All right, this is kind of funky. I don't know how well you can see the screen there. But this is some Pizza Hut order. I guess you can do this online. And somebody had a special direction to cut their pizza into isosceles triangles. And if you note here, I'm really not seeing this pizza cut into isosceles triangles. But that's kind of funny. Okay. All right, this, once again, I don't want you to necessarily write down the book definition because you can always look it up in the book if you need it. Let's go ahead and draw pictures. So we got an if-then statement. Basically, it says if the sides of a triangle are congruent. So if these sides are congruent, meaning it's isosceles, then the opposite angles of those sides are congruent. So in other words, if you know this, then you know what you can automatically write down. You can write down plain long. Those two angles are going to be congruent. Okay? So basically, if you have an isosceles triangle, not only the sides congruent, but your base angles are going to be congruent as well. Okay, with that in mind, segment DE is congruent to segment CD, and you're drawing this picture, right? And you're marking this in. Segment BC is congruent to segment AC. And the measure of angle CDE is 120 degrees. What is the measure of angle BAC? So this is BAC. So right down here, I need to find this one. Okay, using what we just learned, if we know that we have congruent sides, then these are going to be congruent angles. Okay, so this angle is congruent to this one right here. We have 180, think of all the stuff we know. 180 degrees in a triangle. You've used up 20. Okay, most of us know that's going to be 60 degrees. This does not mean each angle is 60 degrees. I have 60 degrees to divide among those two angles or between those two angles. So this one, and it's going to be divided evenly, so we take 60 divided by 2, we get 30, which means this angle is also 30. And just double check, 30 plus 120 plus 30 is 180 degrees in a triangle. All right, now we want to go from this triangle over to that triangle. I wonder how we can get there. What information do I have? What information do I need? Well, what's interesting is I have this angle, and I have this angle right here, which are vertical angles. Notice how that doesn't go away. Vertical angles are congruent. So this right here is also 30 degrees. So basically, I'm a little annoyed at how small my picture is at this point. Bad drawing, but these are congruent. This is 30 degrees, and I need to find this angle down here. Once again, if these are congruent, these sides, then this angle is congruent to this angle. It's almost like you automatically should write that in. When you see isosceles triangles, you've got two congruent angles. Okay? So 180 degrees minus the 30 up there leaves you with 150 degrees. Well, I'm going to divide that evenly between those two. So 150 divided by 2 is 75 degrees. So that angle is 75 degrees. This angle is 75 degrees. Okay, you basically just use everything you know, put it all together, and use your deductive reasoning and figure it out. Example 2. Nice picture, draw it in your notes. Segment AB is congruent to segment BC. Okay? Can I just write it in right now? Isn't this going to be congruent to this angle over here? Uh-huh. You can just do it right away if you want. Angle AC is congruent to, segment. It's congruent to this segment right here. So we could right away say these angles are going to be congruent. Okay? What is the measure of angle ADC? So I'm trying to find this angle right here. Okay. Oh, they do tell us that ABC is 80. So I've got a little piece of the puzzle. So now we start in. I have 180 degrees. I've used up 80. So I have 100 left divided by 2. This angle right here has to be 50. This angle right here has to be 50. Okay, and you're like, but Mrs. Talley, how do I get to the other triangle? I don't have vertical angles. What can I use? What can I use? This is a straight line. I've already used up 50 of my straight line, so this angle right here has to be 180 minus 50, which is 130. So this triangle, this isosceles triangle over here, has already used up 130. So I have 50 degrees left, and I have to divide that evenly between those two angles. So 50 divided by 2 is 25 degrees. So this is going to be a 25-degree angle right here, and this will be a 25-degree angle. And that's what I needed to find, was the measure of angle ADC. We're good. If two angles of a triangle are congruent, then the sides opposite these angles are congruent. Okay, so in other words, once again, I don't need the book definition, just draw your little picture here. If your angles are congruent, if they give you this, then you can tell me this. So if you automatically see base angles congruent, then you can say, hey, this is a nice isosceles triangle because I have two sides that are congruent. Okay, so those base angles stay congruent, but so are your sides. Okay, so it works both ways, basically. Example 3, name two congruent angles that are not already shown, because you can see we've got two congruent angles right there. I see my marking, so automatically I can say this angle is congruent to this angle right here. So angle MLN is congruent to angle MNL. Name two congruent segments. Well, we're not taking the ones that are already on the picture. We have to find another set. So I've got these base angles that are congruent, so I can automatically say these sides are congruent. This side and this side. So PM, segment PM, is congruent to segment PL. Okay? Example 5. Which statement correctly names two congruent angles? And I know, you see those angles right there, that's not what they're asking for. You're going to use these segments that are congruent, and you're going to take this angle right here and compare it with this angle right here. So I need to look, do I have a JML or a JMK? Well, I see a JMK right here, let's check. Congruent to JKM, JKM. Yep, that works, so we're going to go with B. Example 6, which statement correctly names two congruent segments? So now I already have my congruent angles, now I'm working backwards. Which segments are going to be congruent? Right here. This segment with this one. Okay, this gets to be a little repetitive, but we've got MP and PK. We got MP right there. Oh, here we go. PM, the segment is congruent to segment PK. So we'll look at option D. Okay, these are called corollaries. Not that important at this point. I just want you to know the information that's in there. A triangle is equilateral if and only if it is equiangular. Now what that means, once again, this one I'll let you write down that statement, or you can write down the picture. So if, I just want to talk about this little phrase here. If and only if means it works both ways. Meaning, if you have all three angles congruent, then all three sides are congruent. Okay? And it also means, so they don't have to write this thing out twice, they put that if and only if. So that basically, meaning if all three sides are congruent, then all three angles will be congruent. Basically, if you know it's equilateral, then it's going to be equiangular. If you know it's equiangular, you know it's going to be equilateral. Okay, so whichever way to get it in your notes, either this up here or the little pictures. Okay, and then we also need to get this in here. Each angle of an equilateral triangle measures 60 degrees. And the reason that is because you've got 180 degrees total. Equilateral means all three sides are the same, so all three angles are the same. So you divide by 3, every angle has to be 60 degrees. Example 7, triangle EFG is equilateral. So here's EFG on the outside. I'm going to mark it differently. This pink line going in right now means these are congruent. Otherwise, we won't know where our little markings are going to end up being. Okay? EH bisects angle FEG. Okay, so FEG has been bisected, which means I've got this angle congruent to this angle. Okay? Segment EJ, which is this one right here, bisects angle HEG. So then I've got, I'm going to do some other little funky color here. We got this is going to be congruent to this angle. Once again, I'm annoyed. Why didn't I make this picture bigger? Find angle HEG. So to find this angle up here, and find the measure of angle EGH. So EJH. So basically I have to find this one up here and this one over here as well. Okay, let's see where we can get going with this. Started out with an equilateral triangle, which means all of my angles are 60 degrees. Okay? This one's been bisected. Remember how it said this is bisected here? I've got these two markings. So this one must be 30 degrees, and then this one has to be 30 degrees as well. Okay? Then it's been bisected again. This right here, let me draw out just the right side of this picture. And I've got this one coming down the middle. This is a total of 30 up here, but if I bisected it, then each one of these is going to be 15 degrees. Okay? So it's equilateral and it bisects it. So I've got something that's bisected here, and this is a little known rule. I'm not even going to talk about this. You'll have to believe me when I say this is definitely a right angle. 15 degrees, 90 degrees. So I have 180 degrees in this triangle. I've already used up 90, so I've got 90 left. Okay, between this angle and, whoops, do I need to find this one? Yep, 90. So then I'm going to take away 15 that's been used up there. And so this right here should be 75 degrees. Okay, and also, I guess I should explain here. This is going to be a right angle because this has to be 60 degrees. So you have 60 and you have 30 degrees, which is 90, so this is left to be a 90-degree angle. Okay, I think that gets you through that example. And let's work on this one. Triangle ABC is an equilateral triangle. So I can't really put all those little markings in there. I'm just going to highlight this to say all of these are congruent. So we have congruent angles. Okay. And then we go on and it says AD bisects angle BAC. So this angle right here has been bisected. So let's think this is 60 degrees. This is 60 degrees. The whole angle is 60 degrees. But if it's been bisected, angle 1 has to be 30 degrees. Angle 2 has to be 30 degrees. So AD bisects, and we need to find X. So over here, if I just look at this triangle right here, then I have a 60 plus 30 plus 3x is equal to 180 degrees. So I've got 90 plus 3x, you know where we're going. Subtract 90 from both sides. I get 3x equals 90. So x has to equal 30 degrees. All right, if x is equal to 30, what else do I need to find? Find the measure of angle ADB. And watch out in your homework, too, that make sure you answer the question, whatever the question is. They might have two thrown into like one like, it looks like a sentence up there, but it would be a question. So the measure of ADB is right here. And if we know this x is 30 degrees, 30 times 3 is 90, this is a right angle. So what does this have to be? A right angle. So it would also have to be 90 degrees. Lovely. And we're done. End of the chapter. 4.6.